Seventh grade lesson 13.2 is theoretical probability of compound events. So we have been doing simple events, one event, like I roll one die. What are my chances? What are the chances of rolling a 2 on a 6-sided die? 2 out of 6, right? Well, now we're talking about compound events, and that just means more than one simple event. So let's have a look at how we can break these down. And so in this lesson, they are going to show us 3 ways that we can break down the probability of compound events happening. We can use a table or a grid, and this example shows us how to do that. We can use a tree diagram, the next example will show us that, or we can use a list. And so we'll look at all 3, and once you see them once, I think they pretty well make sense. Hopefully I can walk you through and help make everything nice and clear. So they remind us that a compound event, compound means more than one, consists of 2 or more simple events. To find the probability of a compound event, you write a ratio, a fraction, of the number of ways the compound event, that particular event, can happen over the total number of equally likely possible outcomes. So we write it as the same ratio as we've been doing for simple events. What are the chances it can happen over what are all of the possible outcomes, possibilities. And then if we want that probability as a percent, we do the division, this divided by that, and then we move the decimal twice over because percent is out of 100 multiplied by 100. So those pieces are still in play. Those are still what you do. So you're ahead of the game because you already know that part. Let's look at the example for using a table or a grid sort of a thing. We have Jacob rolling 2 fair number cubes. So the simple event would be that he's rolling 1 number cube. But in this case, he's rolling 2. That's what pushes this into a compound event. Find the probability that the sum, remember sum means the answer to an addition problem, sum of the number he rolls is 8. So their step 1 says, well, let's use the table to find the sample space for rolling a particular sum on 2 number cubes. Each cell is the sum of the first number in that row and column. These are the cells they're referring to, and we're going to have to fill in all of the sums, the addition of these all together. Sort of like a multiplication grid, but this one's addition, because we're just adding the number cubes, the sum. So the reason they have 1 through 6, just in case that wasn't clear, 1 through 6, this is representing all of the possibilities of 1 number cube. And this is representing all of the possibilities of the other number cube. So just to put that in perspective, let's say I was rolling a dice and then flipping a coin. Then the grid I would draw would be 6 across the top for the possibilities of rolling the dice, and then 2 on the side for the possibilities of flipping a coin. You could only be heads or tails. It's not going to land on its side, right? So your grid that you set up depends on how many possibilities there are for the items, the compound events that you are doing. In this case, we're rolling a die that has 6 sides, and we're rolling another die that has 6 sides. So that's why there's 6 across here and 6 down, just for clarification. All right, so we're just going to do some addition. I'm not going to make you sit through the whole addition, but I'll do 1 times 1. 1 plus 1 is 2. Then this 1 plus 2 is 3. 1 plus 3 is 4, and so on. And I will do this all the way through. Okay, and you probably, as you were doing that, noticed a pattern on how those numbers were laying out. Math is a lot about patterns. Addition is repetitive, so that's all that was happening. 2, 3, so 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 3 is 7, 4 plus 4 is 8, and you notice 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, all the way through. So we use the table to find the sample space for rolling a particular sum on 2 number cubes. Each cell in the sum of the first number is that row and column. How many possible outcomes are in the sample space? That's all of the cells. There's a 6 by 6 square. So 6 times 6 is 36 little cells in there. So there are 36 possible outcomes. That's going to be our number of possibilities. There are 36 possibilities. Of those, they say circle the outcomes that give the number, the sum of 8. There's one, there's one, there's one, there's one, and there's one. there is a total of 1, 2, 3, 4, 5 chances that that will happen. So there are 5 ways. What is the probability of rolling a sum of 8? There is a 5 in 36 chance. If they want that as a percent, I would do 5 divided by 36 on the calculator. And that division ends up being 0.13888 repeating. So I would just call it 0.14. Different color there, Miss Sanchez. 0.14. Move the decimal twice over for 14%. If they wanted it as percent, that's how you would get it. You take that initial ratio here, do the division, and then move the decimal because of the multiplication by 100% out of 100. Okay, so that's how you do the table version. You just lay out all your possibilities. What are the total possibilities? Out of those possibilities, what are the chances of whatever they asked you is going to happen? And there is your ratio. Give an example of an event that is more likely than rolling a sum of 8. Well, 8 was 5 of them, and they're laid out kind of in this pattern, right? The only one that's got more than 8 there is that 7. So I would say 7 is more likely to be rolled than 8. Give an example of an event that is less likely than rolling the sum of 8. Well, 7 is more, so that's not less, not that one. And 6 is equal amount. Other than that, you're good. 2, 3, 4, 5, 9, 10, 11, 12 are all going to be less likelihood. Hopefully that made sense of how I got those numbers. There's just less of them. So less of them means less likely. More of them, like the 7, more likely. All right, well, we went over the table or the grid version, the grid option or table option of figuring those out. Let's look at the tree diagram. And you may be looking at this going, that's a sandwich, not a tree. I guess the reason they call this a tree diagram is if you looked at this sideways, this could be like the trunk of the tree, and these are all the branches that branch off of the tree. So that's where that kind of comes from. You kind of keep branching things off of the other. So what you'll do with these, and then I'll walk you through this, is if you have like 3 different options or 4 different options of things, then you would take the first option and make a column of it. And then you would take the second option of items and you would give that second option to each of the items in that first column. And then you would take the third set of options and give that third set of options to each of the things that are in the second column. So as you can imagine, it grows quite a bit. Let's look at the example so that that explanation can get clarified a little bit. A deli prepares sandwiches with one type of bread, either white or wheat bread. So there's your first option. So they put that in the first column, white bread or wheat bread. That's your first option. One type of meat is all that they allow. They don't let you put more. One type of meat. So they do one type of bread. You get to choose that. One type of meat, ham, turkey, or chicken. So you can have white with ham, turkey, or chicken. Or you could have wheat with ham, turkey, or chicken. So that second option goes in the second column and it branches off of each of your options on the first column. Then you can have one type of cheese, one only, cheddar or Swiss, one or the other. So we could have cheddar or Swiss with ham and white bread. We can have cheddar and Swiss with turkey and white bread. We can have cheddar and Swiss with chicken and white bread. We can have cheddar and Swiss with ham and wheat bread, cheddar and Swiss with turkey and wheat bread, cheddar and Swiss with chicken and wheat bread. So they branch cheddar and Swiss off for each of the columns in these, or each of the items in the second column. So once we have all of the options taken care of, if they had another option, we'd have to branch it off of these. Can you imagine? It would be a mess. All of these combinations are equally likely that they can happen. Find the probability of choosing a sandwich at random and getting a turkey and Swiss on wheat. Okay, I do the same thing. I need the same ratio. Now on this one, the place that you get the total possible outcomes is at the last column. I would count up how many there are because that's all of the possible options. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes of sandwiches. 12 possible sandwiches. Out of those, what's the chance I get turkey Swiss with wheat? Well, let's go to wheat. So all of these are out. Turkey. So these are out. With Swiss. there's only one possibility that I'm going to get that, right? So the probability of getting turkey and Swiss on wheat bread is a 1 in 12 chance of what I'm going to get. If they want that as a percent, 1 divided by 12, and that calculates out to 0.083333. Repeating, move the decimal 2 times and 2 times only. So an 8-ish% chance of getting the turkey and Swiss on wheat bread out of all of your options there. So that's how you do that. If you had outfits that you wore, maybe you had 2 pairs of pants, one was blue and one was black, you would put blue pair and black pair. And you had 3 shirts, maybe one is white, one is blue, and one is red. You could wear those with your blue pants, or you could wear those same ones with your black pants. And let's say you had 2 pairs of shoes, a brown pair and a black pair. So you could go brown, black with that, brown, black with that, brown, black with that, and so on. Then how many possible different outfits do you have? You would count up all of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, to see how many possible outfits you have. Ooh, I shouldn't have used exactly the same amount of choices, 2, 3, and 2. I don't want you to think that it's always 12. If I had had 3 different shoes, obviously I'd have a lot more choices, so it's not always 12. I probably should use different numbers. Anyways, I just wanted you to get another example of that tree diagram so you could see how that works. Okay, we have covered the table or the grid view like we did for those 2 pairs of dice and the sum of them being 8. The tree diagram we did for the big old sandwich options, and then the wardrobe one that I did as a second example. And now we're looking at the list view, and I know upon first looking at this, you're like, what is this? OMG, OMG, what is this? It makes sense as we explain through, so let's get going and see if we can put it all into place and help it make sense. The combination for Keams, I'm not sure how to pronounce that name. It's a cool name, though. Keams Locker is a 3-digit code that uses the numbers 1, 2, and 3. Any of these numbers may be repeated. Find the probability that Keams' randomly assigned number is 222. So we're going to make an organized list to find all of the sample space, all of the possibilities. And you just have to be real organized about it. That's all this really is kind of just listing out and organizing all potential possibilities. So for the first step, we'll list all the codes that start with a 1 and have a 1 as a second digit. So that's this box right here. You have a first number 1 and the second number 1. So 1 and 1, 1, 2, 3. Or, so there's that possibility. That's 3 possibilities. This is the combo, this is the combo, or that is the combo. List all the codes that start with a 1 and have 2 as a second digit. Maybe I'll color code this here. So this step 1 is this one. And this step 2 says 1 is my first number and 2 is my second number, and all of the options of that, 1, 2, 3. Then list all codes that start with a 1 and have 3 as the second digit. That one. Okay. Now that we have listed all the codes that start with 1, we're going to repeat steps 1 through 3 for codes that start with 2. That's all of these. Different colors start with 2. That's all of these. And then that start with 3. That's all of these. That's a lot, isn't it? So we do that same steps all the way through to get all of the potential options. So now we're going to go ahead and find out how many potential options are there for our combination. And so we know there's 3 options in each of these boxes, right? So there's 3, 6, 9, 12, 15, 18, 21, 24, 27. So there's 27 potential outcomes for this. So that's going to be my possible outcomes. Out of those 27, how many chances are there that the combination is 2, 2, 2? Well, there's only this one right here. That's it. 2, 2, 2. That's the only one. So there's a 1 in 27 chance that his combination code will be 2, 2, 2. As a percent, we would do 1 divided by 27, and that is 0.037037037. I'm just going to round that to the hundredths place. That 7 makes the 3 go up to a 4.04. Then I'll move my decimal over 2 spots over because percent means out of 100. So I'm multiplying by 100, and that is 4%. There's a 4% chance that he's going to get the locker combination. 2, 2, 2. And that's it. Okay, and before I let you fly and be free to do this lesson, the independent practice and stuff on this lesson, I'm just going to show you that last example where we used the list form for the locker combinations, the 1, 2, and 3 thing. I'm going to show you that in tree diagram form. I think I'm wanting to show you that because the tree diagram form is the one that makes the most sense for me. This brain seems to register that. So I'm going to show you how that one looks in tree diagram form. We could have had the first number be 1, the first number be 2, or the first number be 3. So I'm going to put that as my first column. Then we could have had, if the first number was 1, we could have had the second number be 1, 2, or 3. Or if the first number was 2, we could have had the second number be 1, 2, or 3. 1, 2, or 3 for the second number. And then the third number could have been 1, 2, or 3 all the way down for all of these potential options. So that's my third column. And I guess the only downfall is the amount of space that you have. But what you'll notice here is I have 3, 6, 9, 12, 15, 18, 21, 24, 27 possible options. Out of those 27 possible options, what are the possibility that you're going to get a 2, 2, and a 2, 2, 2, and 2? There was just the 1. I'm trying to write the wrong number there. 1 chance that was going to happen, 1 out of 27. So you can still use the tree diagram instead if you like that better. I guess my brain goes kind of sloppy sometimes because that can get sloppy. If you're really very neat and organized, you might like the list way better. And the list one could have been used on the sandwich one, the white bread, wheat bread, ham, turkey, chicken. You could have used that method too. So I just wanted you to see that it could go either way. You're going to find one that you like better and tend to use that more. So anyways, with that being said, I'm going to let my little birdies fly and be free. And hopefully you've been given enough information to feel confident and tackle these independent practice items. Good luck.